Greetings everyone, welcome to today's video, and I will be reviewing the probability concepts and approaches that we talked about during our last two videos. I'll be leaving the links for the two videos in the description box. Don't forget to watch the videos, leave a like and subscription. In case you have any comments or queries, you can leave them in the comments below as well. So for today, we'll be reviewing the probability concepts and do some questions, see how these approaches and concepts come about. So without much further ado, let's jump into the video. So first we talked about what probability was, and in an experiment where outcomes are equally likely, the probability of event E being an event noted as P into brackets A, is the number of outcomes in E, also known as the successes, all over the total number of possible outcomes. And this probability of E ranges from 0 to 1, and 0 when it's impossible and 1 when it's certain. Then as a guide, we said OR means addition and means multiplication, and also talked about the probability approaches and when you need to choose the best probability depending on the question. And you'll see how we can choose these probability approaches in the questions that we'll be doing after this. So the probability approaches of the probability tree, we have the direct probability, complement probability, and combinatorics. If they're not familiar to you, then the links are in the description box. Don't forget to watch the videos. Okay, now let's do some practice question. Here's one, the first practice question of the day. You can pause the video, give it a try, then I'll jump in. Okay, customers are randomly assigned to one of three different chairs. We have three different chairs. If Jacob visits the shop on three separate occasions, what is the probability that he is assigned to a different chair on each visit? So ask if Jacob comes to the shop three different occasions, the first time, second time, third time, what is the probability that he sits in on a different chair? That means he need not or ought not to sit on the same chair in these three separate occasions. So let's say the first time he sits in the first chair, what's the probability of having a different chair for the first one? Of course, there are three choices, so there's no same chairs. We can say the first time he comes to sit, he can take one chair. That's one like probability. He's certain he'll have to sit, so he can sit on either of the chairs. That's the probability of sitting on the first chair. For the second chair, we have two options left. Since he already sat on the first chair, then the second time he'll have a probability of having 2 out of 3 between these two and the third one. And on the third time, he'll only have 1 over 3. Okay. So what's the probability that he's assigned to a different chair on each visit? This and this and third as well. So you have this is 1 times 2 over 3 times 1 over 3, and this will give you 2 over 9, which is answer choice D. Okay, so for the first time, you'll have 3 choices. All of the choices are possible. So he'll sit on one of the chair. That's certain. He'll sit on one chair, and there's no same chairs at that moment. You're sitting in the first chair, so it's 3 over 3. The second time is he'll have 2 choices. That's the second chair and the third chair. So it's 2 over 3 out of the 3 chairs, and then the third will have only that one option out of the 3 chairs. That's 1 over 3, and that will give you 1 times 2 over 3 times 1 over 3, which is 2 over 9. Okay, that was a simple example of the probability. I hope it gives you some motivation to go into the next practice question, and this is the next practice question. Please pause the video and then give it a try. Okay, a fed 6-sided die is rolled 4 times. Now we have 4 rolls. What is the probability that at least one of the multiple of 3 is rolled? Okay, interesting. Now we have fair die, and it's rolled this 4 times, is 4 dashes. What's the probability that at least one multiple of 3 is rolled? We know that die has 1, 2, 3, 4, 5, and 6. And the only multiples of 3 here are 3 and 6. Okay, these are the only multiples of 3 in a die. So we're told what's the probability that at least one multiple of 3 is rolled. See, I've underlined this keyword, at least. This means we can think of it in terms of reverse probability. And is it easier for you to do the reverse or the direct probability? In this case, it's easier for you to do the reverse since you're talking about at least one. In this case, instead of doing the probability of having multiple of 3, which is the direct, we'll do probability of having no multiple of 3. In this case, I will have how many of these numbers are not multiples of 3? We have 1, 2, 4, 5. Those are 4 options out of 6. Okay, so the second option, we have the same 4 out of 6. Third option, 4 out of 6. And the fourth option, 4 out of 6. This is a probability that if you don't have any multiple of 3, even once, that means we do this, no multiple of 3, the probability of having no multiple of 3, and then subtract it from 1. So we know that 4 over 6, that's 2 over 3. So 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. This is 9 and 9. This means the denominator becomes 81, and the numerator becomes 4 times 4, that's 16. Okay. Be careful while choosing the answers. We can choose B here, but that's the reverse probability. And the GMAT will expect you to choose B if you're in a hurry. So be careful on what you need to answer in that particular question. In this case, we have to subtract 16 out of 81 from 1 and have 65 out of 81, which is answer choice D. Right? Be careful with the answer choices.
You're watching Success with Bob Mwiti Show, presented to you by Upstake America. Upstake America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstakeamerica.com. Upstake America, we wake you up to the unlimited potential.
Okay, let's have a DS question in the data in section at the moment. If you're doing the classic edition, then it's still in the quantitative reasoning section. So I can pause the video, give it a try, and then I'll jump in. Okay, each of the 75 leaders attending a conference is either a politician or a CEO, but not both. If a person is selected at random from the attendees, is the probability greater than a third that the person selected will be a male CEO? We have 75 leaders, and they can be either a politician or a CEO, but not both. If a person selected at random from the attendees, is the probability greater than a third that the person selected will be a male CEO? So the first answer choices are A, B, C, D, E. They're always the same. A means the first statement is sufficient, but the second one is not. Also denoted as 1210. You can use that to help you master the answer choices. B says statement 2 is sufficient, but 1 will not be sufficient. These are independently for A and B. Then C, together when you combine them, they are sufficient. D means that each of these statement 1 and 2 independently is sufficient. And then E means even when you combine these two statements, they're not sufficient. So in this case, we have 75 leaders. And they can be politician or a CEO, but not both. We have a politician and a CEO. So if a person is selected at random, from the attendees is the probability greater than third that a person is the probability of that person being selected, say person X, greater than a third that this person will be a male CEO. Okay, so let's go into the statements. We have the first statement. There are 40 women at the conference. Okay, we know that we have 40 women. That means the rest are men. That's 35. You have 40 women, 35 men. So we don't have any other information from this. So can we identify if the probability of having a male CEO will be greater than a third? Say if we have 30 of these men being a CEO, so we'll have 30 out of 75. That will be this a male CEO, and that will give you a value greater than a third. But if we have say 10 men out of 75, which is less than 25 out of 75, right? This is a third as well. So in this case, we have male CEOs being less than a third. So we don't know if of these 35 men, if there are 30 men that are CEOs or there are 10 men that are CEOs. And you can have various values, but in this case, we don't have a sufficient yes or a sufficient no. We need to have a consistent yes or a consistent no. If you have 30 men out of 35 being CEOs, then yes, the probability will be greater than third. But if you have 10 men out of these 35 men that are CEOs, then you have less than 25 over 75, which is a third. And the probability will be less than a third. So in this case, this statement is not sufficient. The statement is not sufficient, and therefore, one is out, and D is also out. Okay, on to the next statement. We have statement 2. There are 20 CEOs at the conference. We have now 20 CEOs. And let's look at the proportion of the CEOs. Out of 20 out of 75, that will be a value less than 25 out of 75, which is a third. So of all the CEOs that you have being male or women, they're less than a third. So if we had to even say all the CEOs that you've selected, 20 CEOs are male, then there'll still be a third. Any value less than those are CEOs. If you have 2 CEOs being women and the 18 being men, then still have less than a third. In this case, this statement is sufficient. And we'll have B as an answer to this question. Here is our third example of the day. So pause the video and give it a try. We have the probability that a customer will purchase a product is 0.75. If 4 customers visit the shop, what is the probability that exactly 3 of them will purchase the product? Okay, exactly 3. So 3, purchase, 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 doesn't purchase. The 4th one doesn't purchase. So probability of purchasing is 3/4 purchase, 3/4 purchase, 3/4 purchase, and not purchasing is a quarter. Okay, so we have exactly 3. So 1, 2, 3 purchasing, and the 4th one not purchasing. So we have 3/4 and 3/4 and 3/4 and 1/4. So you multiply all this, and you'll have this is 3 times 3, that's 9 times 3, 27. And have 16 times 16, that's 256. Okay, yeah, 27 over 256 right there. But be careful again with the answer choices. In this case, yes, we have 27 over 56, but we've missed something. Might be the last customer will have but doesn't purchase, or the third customer will not have purchased, or the second customer, or the first customer. In this case, we do a 4 choose 1 for the number of displacements of this people that doesn't purchase this product. So 4 choose 1 also 4 choose 4. This gives us 4. All right. These are a number of distributions of this P bar on this list. You can have the first customer not purchasing, the second customer not purchasing, or the third customer not purchasing. So you'll have a 4 choose 1 times whatever we had, 27 over 256, or 4 times 2, 27 over 256, and this will give you 27 out of 64, which is answer choice C. Okay, hope that's clear. And we have another example here. So you can pause the video again and let's give it a try. So a shopping cart contains 6 red apples and 4 green apples. If you selected 4 cookies at random, what is the probability that you select 2 of each type? Now this is more of a probability combinatorics approach, and this is where you use combinatorics approach for this question. Okay, so a shopping cart contains 6 red apples and 4 green apples. We have to select 2 of each. So out of this 4, we have to select out of the 6, you choose 2, and out of the 4 green apples, you choose 2. So you can have a total of 4. And out of this 10 apples combined, you choose 4. Okay, and this is how we do this particular question. The moment you find the approach to the question, probability becomes much easier. So you're selecting 2 of each. You select 2 from the red, 2 from the green, and 4 from all the 10 possibilities. Okay, so 6 choose 2. This is 6 choose 2 will be 6 factorial, 2 factorial, 4 factorial. Also 6 times 5 times 4 factorial, all over 2 factorial times 4 factorial. This cancels out. 2 factorial is 2 times 1, which means just 2 by 2, 1 by 2, 3. This is 15. 4 choose 2. This is 4 factorial, 2 factorial times 2 factorial. This is 4 times 3 times 2 factorial, all over 2 times 2. Since 2 factorial is 2, 2 factorial is 2. Also 2 factorial is 2 here, so it is cancels out, and have by 2, and this is 2. This is 6. And lastly, 10 factorial over 4 factorial. For 10 choose 4, that's the denominator, all over 6 factorial. This gives us 10 times 9 times 8 times 7 times 6 factorial, all over 4 factorial, which is 4 times 3 times 2. We don't need to add the 1, then times 6 factorial. The 6 factorial cancels out. We'll have 4 times 3 times 2. We have 10 here, so we can have a factor of 4 from 4, 1. A factor of 4 from 8, that's 2. We have a factor of 3 from 3, that's 1. A factor of 3 from 9, that's 3. A factor of 2 from 2, that's 1. Another factor of 2 from 2, that's 1. So you have 7 times 3 times 10. This is 21, 210. Okay, so this example here, or this calculation here, simplifies to 6 choose 2, which was 15, times 4 choose 2, that was 6, all over 10 choose 4, that's 210. Okay, a factor of 3 from 6, that's 2. A factor of 3 from 210, this is 70. Okay, this is 30 out of 70. And this gives us, if you simplify 30 out of 70, this gives us 3 over 7, which is answer choice B. I hope you also got that question right and you're having fun in the video. So let's have homework for this particular video or session. It's new for us, but you can give it a try, and you can share your comments in the section, comment section below. So you have, if an integer n is selected at random from 21 to 100 inclusive, what is the probability that n times n minus 1 times n minus 2 will be divisible by 8? Think of this question in terms of even and odd as well. Think of this in terms of factors and multiples, and to see how probability can be included in the number theory section. And so hope I all enjoyed the session. I'm Clifford Mwenda at GMAT trainer with the Kenya Live program, and it has been intuitive and fun sessions, the last 3 sessions for you. In case you have any questions and queries as well, or any recommendations, then you can put it in the comment section below. So thank you for coming. Have a lovely day. Bye-bye.